Hello all. In this video we're going to take a look at Mediapipe's pose detector, and we'll look at generally what it looks at and what it does, but also some code that runs it on a video. And I'm going to show you a couple of different videos because I want to point out both some strengths and limitations that the model has. And then we'll kind of wrap things up. Let's take a look first at what this is all about anyway. So what do we mean by pose? Pose in this case means body pose, like where are the parts of your body in space. And Mediapipe's pose detector has 33 landmarks on the body. You can see this in the video that I've got here, in the slides that I've got here. There are fewer on the body, on the face. So it has usually like right under the eyes, your cheeks, and then a nose, and not much else that it detects on your face. But it does build a skeleton, much like the hand skeleton we looked at earlier. It builds a skeleton of your body parts: your shoulders, your hips, your feet, your knees, your elbows, your hands. Not as detailed as the hand detector, but also very useful. Another thing that it also produces is a segmentation that shows what in the image it thinks is part of the person. So for this particular image, you can see that it did a pretty good job of coming up with the skeleton, but it also is doing an excellent job of segmenting the person from the background, which is not a trivial task on a picture that's dark, where someone's wearing a dark colored clothing and there are dark things in the background as well. So that's fairly impressive. All right, let's take a look at the code. I set this up a little bit different this time because I have these videos, some of which I want to try. The code is just like the others that we've been doing. We import similar things. We load the pose landmark detector, and we use the basic default options for it, and we're going to run it on a video. Now, what I'm going to do here, I will run it on my camera, but it's hard for me to get far enough away from the camera to actually show the whole thing. That's why I want to show some of these videos that I have stored. So right now, I was testing, so I'm just going to comment out what I was doing before. I'm going to pass 0, which says use the default webcam, and we'll run it and we'll see what it actually does. All right, now I'm going to go and switch over. So here I'm really close to things. You can see it's finding these arcs that are either my eyes or my cheeks. It's got a point from the nose, it's got a line for the mouth. But you can also see that it's trying to detect other parts of my body. If I slide away, I can get it to at least give the landmarks for my upper body. It is reporting positions for all of the invisible parts of my body as well, not just the parts it can actually see. So it does actually try to predict where the rest of the body might be. Obviously, it's not going to be super accurate in the case where the body is not visible. All right, now what I want to do, I'm going to go back to PyCharm so you can see the code a little bit more clearly. We're going to try a couple of sample videos that I happen to have. So the first one here is Chaplin.mp4. This is Charlie Chaplin, silent movie comedian type person. What all I'm doing is changing, so I pass a path to that video. And we'll take a look at what it does when you run. All right, we'll run the Chaplin video and we'll see what it looks like. I should make sure to change over so you can see the whole screen. All right, so until the feet shows, it doesn't really do the legs very well, but it does get the whole body. That's a very short clip. I'm going to run a longer clip, and I want you to know that this will look very slow. It is a little slower than the original video, but this is a video of a woman on a beach. It is already in slow motion. So this does not reflect the running speed of the body pose detector, just because it is, in fact, a slow motion video to start with. This is quite challenging as videos go. it shows a person who is not just walking along or standing still. She's moving in interesting ways. She's dressed in dark clothing that kind of hide her body parts. And the background includes some dark clothing as well. She's kind of dancing on the beach. So you can notice that the model is not perfect. It does lose track of things at certain points, but given the difficulty, oh, they're going really crazy. Thought she was upside down. But given the difficulty of this task in this case, it's not bad. I'm actually quite impressed that the model was able to track her so well. And as I said before, this is a slow motion video, so it's not slow because of the processing speed. Okay, we're going to stop that one. I want to show you some others to show you some limitations of this model. So I have a video here. I actually might just run this. So this is a video showing a bunch of people running a race. You would think this might be an easy task for the model, so we'll just try it. This is what run.mp4. All right, so it didn't really seem to catch people. We can see that even better in this people video. Oops, sorry. Here's a video showing people walking. I think that's in Grand Central Station in New York. It didn't detect a single one of them. Why not? Because it wasn't trained on data of people that far away. The body pose detector is meant to detect people who are within a reasonably close proximity. So it can detect parts of me when I'm very close to the camera. It can detect someone who's back far enough that you can see their feet. But as they get really far away, that it was not trained to detect those people, and it will not do a very good job. We're also in that video up above them. In both of those videos, we're kind of up above, and that's also not the kind of data it was trained on. So you have to be kind of careful with models like this. Sometimes they do what you want, and sometimes they don't do what you want. You just kind of have to be cautious. All right, so I want to take a look at the data that you get when you run this landmark detection. Again, you're getting pose data back. It's going to be complicated, much like the hand, and we have also the segmentation of the person. I meant to show that to you in the code, but I'm not going to worry about it right now. So when you call detect, you get back a pose landmarker result, and it has again 3 variables within it. Each contains a list, and those lists are all the same length because each of those lists corresponds to each of the people that was detected. The default is that it will detect one person, but you can ask it to detect more than that. So it is set up with its results to allow you to detect multiple people. So pose landmarks and pose world landmarks, these are similar to what we had for hands. The pose landmarks, each of these sublists is a list of, in this case, 33. It says 21 there, but it's wrong. 33 different normalized landmarks, and with the world landmarks, they're 33 landmarks, which are real world units, which in this case I think might be meters. But again, don't quote me on what the units are. I believe they're centimeters or meters. In addition, for each person who's detected, we have a segmentation mask. That's a black and white mask that shows us where in the image it thinks the person is. So these can just be displayed, and you can get a really nice, easy segmentation of the person from the background. All right, this is a nice example of a very powerful tool. You can use the results you get to do all kinds of applications. I've had students who've worked on things like whether someone is making the correct movements in a physical therapy exercise, whether or not someone is making the correct martial arts move, whether or not someone is making standing with a particular pose. So they played a game of Simon Says and used this to detect whether the person was doing it. Another set of students of mine used this model to determine whether or not to teach people how to do silly dances. And detect when they were doing them correctly. So there's a lot of nice, fun applications for this, but you do have to be aware, like any model, it only really works on the things it's been trained on. It has limitations, and if you press it, you will definitely find those limitations. Having people who are too far away from the camera is going to be a problem for it. It also is tuned toward detecting very small numbers of people, so it's not really aimed at finding all the people in a crowd scene or something like that. Anyway, this will be the last of the videos I'm making about the Mediapipe models. They are great. They're fun to play with. They're really easy to use. I'm very thankful to the Google research team that worked on these that has made them public because they enable us to build upon them and do some really interesting and fun applications. And I will stop there. So I will see you again soon. Bye-bye.